In this video, we're going to look at pollution from combustion. So the first thing we're going to look at is unburnt hydrocarbons. They cause something called low-level ozone, which can cause or make worse our respiratory problems. So things like asthma might be made worse. And these come when this happens when they react with NOx gases, which are the nitrogen oxide gases, to form the low-lying ozone, the low-level ozone. Then we've got carbon dioxide, which we know causes global warming, and that comes from complete combustion of fuels. Then we've got carbon monoxide, which is a toxic gas, so it can kill us, and that comes from incomplete combustion of fuels. Then we've got carbon, which is particulates of soot in the air, which cause respiratory problems. So again, makes our asthma worse. If we suffer from respiratory problems, this will make it worse. From further incomplete combustion. And then probably the most important two, so we maybe put little stars on these two. These two gases, these are non-metal oxides, and non-metal oxides are acidic and contribute to acid rain. Remember, this also causes our low-level ozone or photochemical smog. Now, these two are really important. They come up in the exam a lot, and you've got to be able to explain why they arise. So this is nitrogen and oxygen from the air, but they don't react all the time. React at the high temperatures of the engine. So in the car engine or the jet engine or the train engine, they react at the high temperatures of the engine. So we get this N2 plus O2, and the equation the exam board want is to give 2NO. This is a special one, so we need to sort of like highlight this one, yeah, and this one as well. These come up a lot. So where about the sulfur dioxide? Well, sulfur impurities in fuels. And why would there be sulfur impurities in fossil fuels? Well, fossil fuels are coming from fossils, that's dead plants and animals that have fossilized over many millions of years. They are protein-based structures. Proteins have disulfide bridges, contain sulfur. So there are sulfur impurities in the fuel, and that reacts with oxygen from air. And so we get S plus O2 makes SO2. And the exam board like these two more than any others because of these equations and these explanations. So our next thing is to look at how we can deal with some of this pollution. And so we're going to have a look at how we can deal with it. So one of the things that we do with a car is we attach a catalytic converter, and that removes carbon monoxide, nitrogen monoxide, and the unburnt hydrocarbons. So it's removing 3 of our pollutants. And it does that by having a honeycomb structure on a thin layer of some expensive metals, so platinum, yeah, or palladium, or rhodium. These 3 metals appear together in the periodic table if you look them up. So a thin layer is used to reduce the amount of expensive metal needed. These metals are expensive, and it's done on a honeycomb structure. So we've basically got this kind of like tessellating hexagons honeycomb structure made of pot, ceramic, and we've coated it with the expensive metal, but the honeycomb structure provides us with a large surface area. So what that does is it takes the NO and it reacts it to produce CO2 and N2, which are less polluting. So can we balance this equation? So we're trying to make N2 and CO2. And you probably want to put this in a box or something, because this is quite important, comes up in exams quite a lot. To balance this, we need 2 here, 2 here, and 2 here. Alternatively, you could have put a half in front of nitrogen. The unburnt hydrocarbons, well, the catalytic converter just gives them a second go at burning. So it takes them and it reacts them with oxygen. So can you write an equation for the complete combustion this time of octane? So for example, 8 CO2s, 9 waters. So that's 16 oxygens there and 9 more. So that's 25, so 12 and a half. Or it takes the unburnt hydrocarbon and it reacts it with nitrogen monoxide to make carbon dioxide, water, and this time some nitrogen, less polluting products. Can you balance that equation? So you do 8 and 9. This time we have to go back and balance the oxygens on with the NO. So we've got 16 and 9 is 25. Which means we've got 12 and a half nitrogens this time. And the other thing that we did mention in the group 2 pack is that power stations that would produce a lot of SO2, which is an acidic gas, can be coated with either calcium oxide, so can you remember what was made, or calcium carbonate, to neutralise the acidic gas, to remove the sulfur dioxide and turn it into the salts, calcium sulfate salts. But just remember, these are calcium sulfate 4 salts. And this one produces CO2 as well.